Welcome back to the station. I'm your host, Trevor Shelley. So far on our journey, we have explored the birth of the railroad, the power of the steam, the building of the transcontinental railroad, and the golden age of luxury rail travel. But today we arrive at a darker stop in railroad history, because while trains helped build nations, move millions, and change the world forever, they also carried risk. And when things went wrong on the railroad, the consequences could be catastrophic: collisions, derailment, bridge collapse, human error, manufacturing failure. Some of the worst railroad disasters in history were tragedies that shocked the entire nations. But those disasters also forced change. They pushed railroads to improve signals, brakes, communication, track safety, and passenger protection. Today's stop: train disasters that changed railroads. All aboard! So in the early days of the railroad history, trains were revolutionary, but they were also dangerous. Railroad systems were still developing. Many railroads lacked reliable signalizing systems, standard safety rules, strong braking systems, modern communications between stations and crews. In the 1800s, railroads often operated with limited technology. Trains could end up on the same track heading towards each other. Engineers sometimes relied on heavy written orders, station signals, or rough timing estimates. Add in poor weather, track defects, worn bridges, and the speed of expanding rail networks, and you had the perfect conditions for disaster. As railroads grew, so did the stakes: more passengers, more freight, more trains on the line, and when accidents happened, they could be devastating. Checking something out real quick, guys, on here. Bear with me. I am actually just seeing 0, 8. Okay. That's all I needed. One of the famous early railroad disasters in the United States was the Great Train Wreck of 1856 in Pennsylvania. This tragedy happened on the North Pennsylvania Railroad near Fort Washington. It involved two trains traveling towards each other on a single track. One was a regular scheduled train passenger. The other was a school train carrying hundreds of school children, and adults on a holiday trip. Because of the delays and miscommunications, the two trains ended up on the same line at the same time. They collided head-on. The train crash was horrific. Dozens of people were killed and many more were injured. The disaster shocked the public. It exposed how dangerous single-track operations could be when railroads depended too heavily on timing and human judgment alone. And it helped drive demand for better dispatching, stricter scheduling, and improved signaling systems. Now let's go to Scotland. In the 1879, the Tay Bridge Disaster remains one of the most infamous structure failures in railroad history. A passenger train was crossing the Tay Rail Bridge during a violent storm. As the train moved over the bridge, central sections collapsed. The train plunged into the icy waters below. Everyone on board was killed. The disaster stunned Britain. This wasn't just a train accident. It was a bridge failure, a classical engineering collapse. Investigators raised major questions about the bridge design, construction quality, wind resistance, and inspection standards. The Tay Bridge Disaster became a major lesson in a civil engineering and railroad infrastructure safety. It showed that the rail's safety wasn't only a local motives and crews, it was also structures carrying on the train. As accidents occurred in the 19th century, railroads and governments began looking for solutions. Several key technologies changed everything. Blocking signals instead of allowing multiple trains in the same area of track, railroads began dividing routes into blocks. Only one train could occupy a block at a time. This dramatically reduced the chance of collisions. Automatic air brakes. Early trains often relied on hand brakes operated manually by the brakeman. This was slow, dangerous, and unreliable. Then came the air brakes, which allowed the engineer to apply the braking power to multiple cars at once. That made stopping trains much safer and faster. Automatic couplers. In the early railroad days, railroad workers had manually link train cars together. This was extremely dangerous and it caused many injuries. Automatic couplers reduced the need for workers to stand between moving cars. These improvements didn't happen overnight. They often came after serious accidents made it impossible to ignore the dangers any longer. The Hero and Weldingstone railroad crash became one of the deadliest railroad disasters in British history. In dense fog, a local train was struck from behind by an express train. Then another train moving in the opposite direction collided with the wreckage. The result was devastating. More than 100 people were killed and many more were injured. This disaster put renewed attention on signaling systems, driver awareness, and automatic train protection. It showed that even in the modern era, one mistake combined was poorly visible, and speed could lead to catastrophe. This crash helped strengthen calls for improvement, warning systems, and train control technology. Now to Germany in 1998. 17 derailment involved a high-speed intercity express train. At the time, it was only one of the worst high-speed rail disasters in history. The accident began with a broken wheel tire, a mechanical failure that caused the train to derail at high speed. Cars crashed into the bridge. Supports and destructions was catastrophe. More than 100 people were killed. The decelerating disaster was a major turning point for high-speed railroad safety. It led to closer inspections of wheel design, maintenance procedures, and engineering standards for high-speed trains. It was a reminder that as trains became faster, the margins for error became even smaller. Over time, disasters pushed the governments and railroad companies to create stronger and safety rules. In the United States, railroad companies and safety laws and federal oversight grew as the industry matured. Railroads faced increased pressure to improve brake system, car design, track inspections, bridge safety, communication systems, crew training. One of the themes that appear again and again in history. Safety improvements often follow tragedy. That's a hard truth, but also an important one. Every major accident became a lesson written in steel, smoke, and loss, and those lessons saved lives later. So what did the train disasters teach the world? They taught that the speed without protection is dangerous. They taught us that infraction must be inspected constantly. They taught us that communication saves lives. They taught that engineering details matter. And they taught that public trust in railroad travel depends on safety. Modern railroad systems are far safer than early railroads because generations of workers, engineers, investigators, and lawmakers learned from painful failures. The railroad industry changed because it had to. Train disasters are some of the most tragic chapters in the railroad history, but they are also some of the most important because every safety signal, every improvement brake, every stronger bridge, and every better inspection system exists because railroads learned hard lessons over time. Next time here at the train station, Trevor's Train Station, we move from tragedy to conflict. We'll explore how trains were used in times of war, carrying troops, weapons, supplies, and sometimes become weapons themselves. Next up, Trains at War. I'm Trevor Shelley. Thanks for stopping by the train station. And remember, all aboard, next stop history.